Alright, so let's go through the 2018 A-level question. So we have this part A, right? State the principle of moment. So this one is just a definition. So I just do a quick one. So for an object to be in rotational equilibrium, the sum of clockwise moment must be equal to the sum of anti-clockwise moment about a pivot at any point. Alright, so that's the first part. Okay, for part B, right, we have this metal sign of uniform thickness. Okay, so we are given all the different dimension, right? Then we are given the mass of the sign to be 4.5 kg. Then the center of mass is so and so forth. So part I, right, they ask us to determine what is the magnitude of each tension if the ratio of the tension of the two support is given as 3/7. Okay, 3/7, to be frank, I think I put wrongly already. Okay, 3/7 is the tension, right? Okay, so if you look at A and B, apparently, as seen from the diagram, A, the CG is nearer to rope A, meaning that rope A should have a higher tension. So the TA must be bigger. Then what about TB? Tension of B must be smaller, right? Okay, so with this, right, I know that this is 3/7, meaning that 3:7. So what is the 3? 3 is the TB. Then the 7 is the TA. Okay, so with this, I can actually know one thing is that my this thing is in equilibrium. So I don't use for this type of question, I don't use the POM, principle of moment. I use the resultant force because they never ask us to use the POM, right? So with this, I know that my total upward force must be equal to the total downward force. So the total downward force is just the weight, right? So 4.5, remember to multiply by 9.81. So this will be the weight. Let me just do a quick calculation. So the weight is roughly 44.145 Newton. So meaning that the total tension A and the tension B, right, the sum of TA plus TB must be equal to the total downward force, such that there's no resultant force in the vertical direction. So I just put TA plus TB, right, is equal to 44.145 Newton. So I know that the total, the so-called, if you look at the ratio, right, the total units is about 10 units. So 10 units is equal to 44.145. So what is 1 unit? So 1 unit is equal to 4.4145 Newton. So I want to determine my TB and TA. Let's determine our TA first. So TA is 7 units. So tension A is equal to 4.4145 times 7. So just 4.4145 times 7 units is roughly 30.9015 Newton. So of course you round off to 3SF, 30.9 Newton. So this is 30.9 Newton. Okay, what about TB? TB simple. So it's just 3 units, right? So first, TB is equal to 3 multiplied by 4.4145. So this will give you, let's see, 5 times 3. Okay, so this will be equal to 13.2 like that. 35. Then round off to 3SF, 2 Newton. Okay. Yeah, so as such, part I, the answer will be 30.9 plus 13. Of course, TB is 13.2 lah. So for this, I think the difficult part is actually to determine which one has a higher tension. Just think of one thing is that if you look at part I, 3/7, right, not necessarily all the time the top refers to the A, then the bottom refers to the B. Not necessary. So you must really infer and a bit of your own discretion. Okay, for part 2, for the next part, using an answer in BI, right, determine the horizontal distance D to the CG, right, from the left edge of the metal sign. So let's go back to the diagram. So we are asked to determine what is this distance. Okay, so with this, right, okay, high chance I will need to use the principle of moment. So principle of moment, so let's just say I put for example, I put a pivot at this point. Okay, I use maybe this side. Okay, let's just say I put a pivot right here. So this is the pivot. Okay, so I apply the POM, principle of moment. So CW is equal to ACW. Okay, let's determine what is our CW. CW definitely is your, what's it called, the weight, right? Because you look at this, right? This is the pivot right here. Then you look at the weight, direction of weight is like that. So this is your CW. Okay, so let's determine our CW moment in terms of T. So the weight, okay, so force times distance. So force times perpendicular distance. So it is equal to 44.145 multiplied by T. Is equal to the anti-clockwise moment. Okay, there are two anti-clockwise moments. First will be your TA. Then second will be your TB. Okay, let's determine our TA first. Okay, so anti-clockwise like right here is equal to TA. Okay, TA we know is roughly 30.9. Okay, just use the rounded off answer. 30.9 multiplied by from the force to the pivot. So it's from 0.2. So this is 0.2 plus the second anti-clockwise is the TB. Right? Okay, so TB is about 13.2 multiplied by the perpendicular distance, right? So the perpendicular distance is from here all the way to here. So it is 1 meter minus away 0.2, about 0.8. Okay, so this will be the two anti-clockwise moment. Then just manipulate. So let's determine the D plus 13.2, 0.8. Okay, so the total sum of the anti-clockwise, right? So this two ACW is roughly 16.74. So D will be equal to okay, so the D D will be roughly equal to 0.379204893 round off to 3SF 0.379 meter. So this part is roughly 0.379 meter. So that is how you solve, right? Okay, so with this, I will move on to the last part, which is a qualitative question. So let me just write down. Okay, so horizontal wind now blows on the face of the sign such that it is given as such a orientation. So explain why a force exerted by each support, right, on the sign has a horizontal component. So if you think about this, right, it's very similar to the previous, the so-called the 2016 question. So imagine they have a metal sign, the weight, right? So this is the weight. So definitely the sum of the downward force must be equal to the sum of the upward force such that there's no resultant force in the vertical direction. So this is given as the rigid support. So the tension TA plus TB must be equal to the weight. Okay, so now there's a wind, and this wind is causing the metal sign to be in this orientation, and meaning that it's still in equilibrium because it's not moving, right? It's not moving, it's not rotating. So if you look at this, right, the wind is exerting a force in this direction, meaning that the support must have a horizontal component. There's a horizontal force component towards the left hand side such that this and this, right, will eventually cancel out so that there's no resultant force in the horizontal direction. So that is how you actually explain. So you just say that, because the sign is still in equilibrium, meaning that there's no resultant force. Since the wind is exerting a horizontal force on the sign towards the right hand side, towards the right. Means that the support must have a equal and opposite horizontal force such that there's no resultant horizontal force. Alright, so that is how you actually write down this qualitative question.